We want these second derivatives. They're probably going to get a little bit hairy. That's okay. We can handle that. Let's derive the first one. It's a. So to get the second derivative, you got to start somewhere. And that's going to be starting with the first derivative. So y squared is 2y dy dx equals 2x plus 2. Not too bad. So dy dx is just 2x plus 2 over 2y, which the 2's all cancel, 2x plus 1 over y. Now, with the second derivative, we got to do the quotient rule. So the second derivative of y with respect to x twice is, derive the top is 1 times y minus, derive the bottom is dy dx times x plus 1. All of that is over y squared. Simple enough. You never ever leave dy dx in there like that. You got to rewrite what it is. So it's y minus x plus 1 over y times x plus 1. All of that's over y squared, and really that's the derivative. That's fine. We're going to simplify it though, just in case we have to work with it. It's a little bit easier to simplify. We don't want y on the bottom here, so you just multiply by y over y. And you should be getting the hang of this. When you simplify fractions, you got a complex fraction, multiply through by whatever the complex common denominator is. That's going to give us y squared minus x plus 1 squared, because the y and the y are going to cancel, x plus 1, x plus 1. All of that's over y cubed. And that's fine. You can leave it like that. You can probably simplify a little bit more if you look back at your original equation. I'm not worried about it. Leave it like that. We're good. Actually, I'll just show you what I'm talking about. If you keep simplifying this, check this out. You're gonna get y squared minus x squared plus 2x plus 1 over y cubed. That's if you expand that out. Now, the reason I'm showing you this is because if you just look at x squared plus 2x, let's go back to our original equation. X squared plus 2x, if the points on this curve, has to equal y squared. Well, that means this thing equals y squared minus x squared plus 2x is y squared plus 1 over y cubed. But all that is, y squared minus y squared goes away, is negative 1 over y cubed. So that is a much, much nicer answer. But if you didn't see that connection there, you could have left it like this as well. I don't think there's anything wrong with that. But usually these things end up simplifying down a little bit nicer, especially if it comes from a textbook or something. It's usually going to end up being a kind of a nice derivative. And if you're checking your answers in the back, and they have, like, if you have this, and they have something like this, you just shouldn't be freaking out. You should be like, oh my God, how did I do something wrong? You didn't really do something wrong. They simplified it further than you did. That's all. All right. Number 2, or 4b, 2x. This is a circle. 2x plus 2y dy dx equal to 0. dy dx equals negative x over y. So then the second derivative, the quotient rule, is negative 1 times y minus negative x, which is plus x, times the derivative of y over y squared. Okay, negative y plus x. You never ever leave dy dx in there, so we rewrite what dy dx is, which is negative x over y. Negative x over y. Over y squared. You don't want the complex fraction, so you multiply by the denominator. And this is going to give us, multiplying by y, negative y squared minus, the y's cancel, so x times negative x is negative x squared over y cubed. And this, now that's a fine answer as well. You can leave it like that. But again, if you look back at your original equation, you can factor out a negative here and you'll be left with y squared plus x squared over y cubed. And y squared plus x squared, if we're on the second curve, is 100. So it's really negative 100 over y cubed. The reason that's happening, this looks a lot like the last one we did as well, and the reason that's happening is because if you look at the last one, that's also a circle. It Yeah, they're both circles, which is why their second derivatives look very similar. Except the first one's going to have a radius of 1, and this is going to have a radius of 100. Okay, so that's the second derivative. Let's keep going. The third one, C here, x squared minus y squared is a hyperbola. That's not important for this problem. I'm just jogging your memory here about some things you might have learned about these guys. So x squared minus y squared, deriving that. Please get out of here too. 2x minus 2y dy dx, that's going to equal 0. And dy dx is going to be x over y when you solve it. Minus 2x divided by negative 2y. You get that. So the second derivative is going to be, quotient rule says, derive the top times the bottom, minus derive the bottom times the top. Or you can use high d low, low d high minus high d low, same thing. Over y squared. You don't want dy dx in there, so you rewrite it as minus dy dx is x over y times x over y squared. You don't want the complex fraction, so we're going to multiply by y over y. And this is all very similar to the last couple ones we did. Y times y is y squared, minus y times this is going to give us just x squared because the y's are going to cancel, over y cubed. That's going to equal, and again, x squared minus y squared is 25, so we can factor out a negative here, really. Negative x squared minus y squared over y cubed. And that's really negative 25 over y cubed. Again, similar derivative because it's similar to the circle, except it's a negative y cubed there, so we get something a little bit different, I think. Okay, and the very last one, finding the second derivative. Deriving 1 turns into 0, deriving this turns into the negative y plus x dy dx. You gotta put it in parentheses, otherwise you lose a negative. And that equals 1 minus dy dx. Solving for dy dx, just distribute that negative. We're gonna have 1, this is an equal sign. Negative y over here, we're going to add it, so this will become plus y, over, here we're going to have negative x dy dx plus 1 dy dx, so on the bottom we're going to have plus 1, so it's positive 1 minus x. Okay, second derivative. Just following some rules here. Derive the top is 1 plus y turns into dy dx. Times the bottom, which is 1 minus x, minus the top, 1 plus y, times 0 to the bottom, negative 1. All of that is over the bottom squared, 1 minus x squared, which is equal to dy dx is 1 plus y over 1 minus x, times 1 minus x, and that's pretty nice because they're going to cancel out there. Negative 1, oh man. Should put parentheses around that. That was close. Negative 1 and minus turn into a plus. So it's plus 1 plus y. Over 1 minus x squared. And simplifying this down. 1 minus x is cancel here. We have 1 plus y plus 1 plus y. So that's 2 plus 2y. Over 1 minus x squared. And that's our second derivative. As long as I didn't make any mistakes. And if I do make any mistakes and you see that, please shoot me an email or just make a comment about me making dumb mistakes, because it's possible, I know. That's it. Hopefully you enjoyed it. Hopefully you feel better about implicit differentiation.